With this problem, we're changing things up a bit. We are still going to use the disk method, but we're going to rotate this region about the y-axis. So let's take a look at this graph first. If you want to know what y equals the square root of 4 minus x squared looks like, you can square both sides first, then you can add x squared to both sides, and you can see that we'll get a circle with a radius of 2. Of course, since y was defined to be the positive square root, this graph will just be the upper half of that circle. You'll notice that we're also bounded by x equals 0 and y equals 0. So the region that we're going to rotate looks like this. Now if we're going to use the disk method to rotate this region about the y-axis, we need to slice this region up this way and rotate each one of these pieces about the y-axis. Since we have to slice this region horizontally, you'll notice that the thickness of each one of these disks is actually now dy, meaning that our integral will be with respect to y. But we're still talking about disks, so when we add up the volume of each one of these little elements, that volume is still going to be just pi r squared dy. You'll notice that no matter where I sliced this region, the radius of this disk is going to be given by the equation of the circle here. In fact, each one of these radii will be given by the x value on the equation of that circle. So what we can do is we can solve this equation of the circle for x. X is going to be the square root of 4 minus y squared. That is the radius that we're looking for. So we can plug that into our volume. The limits now have to be limits on y. So the smallest y value in this region is 0, and the largest y value in the region is 2. Now we can simplify and integrate. The first step of simplification is realizing that the square root and the square cancel. This gives us what should be a pretty straightforward integral to complete. Integrating 4 gives us 4y. Integrating y squared gives us 1/3 y cubed. And we're going to evaluate from 0 to 2. Plugging all of that in and doing just a bit of simplification. Let's see, 8 is 24/3 minus 8/3. The final answer should be 16/3 pi. And that is going to do it for that problem. Again, this is a volume, so these would be units cubed. But I'm going to zoom out on that and call this problem complete.